Download this code from codegive.com, link in the description below. OK, let's dive into the 79th Airhacks.tv episode, focusing on the question and answer session, providing detailed explanations, code examples, and alternative approaches where relevant. This is a comprehensive breakdown, and it will be lengthy, so get comfortable. Airhacks.tv, 79th episode, question and answer session, a detailed deep dive. While the exact content of each Airhacks.tv episode can vary slightly depending on the specific questions asked live, the series tends to revolve around common Java EE, now Jakarta EE, development topics, including Java EE and Jakarta EE technologies, contexts and dependency injection, CDI, JPA, jax-rs, JSF, servlets, websocket, bean validation, json-p, json-b. Architectural patterns, microservices, domain-driven design, cqrs, event sourcing. Development practices, testing, unit, integration, end-to-end, build tools, maven, gradle, continuous integration / continuous deployment, CI/CD. Performance tuning, profiling, optimization strategies. Security, authentication, authorization, security contexts. Because I don't have direct access to the transcript of the 79th specific episode, as Airhacks.tv is a live series, I'll provide answers and code examples to questions that are very likely to have been addressed in similar sessions, covering the common themes listed above. I'll also address how to find relevant information on common Airhacks.tv topics. Important note: this is a simulated Q&A based on the general scope of Airhacks.tv. It is structured to mimic what you might expect. Let's get started with the hypothetical questions and answers. Question 1. I'm struggling with choosing the right scope for my CDI beans in a web application. Can you explain the differences between @request scoped, @session scoped, and @application scoped, and when I should use each? Answer: This is a very common question in Java EE/Jakarta EE development, and scope management is fundamental to CDI. @request scoped lifespan a bean annotated with @request scoped lives for the duration of a single HTTP request. A new instance is created at the beginning of the request, and it's destroyed when the request processing is complete. This is ideal for beans that hold data specific to the current request, like user input from a form, a database connection used only for that request, or a shopping cart's contents during a particular checkout step. Use cases: handling form submissions, managing request-specific resources, processing REST API calls. Concurrency: generally thread-safe within the scope of the request, as each request has its own instance. Important: if you inject a @request scoped bean into a bean with a wider scope, example @session scoped, the @request scoped bean will still only exist for the duration of the request, but you might encounter issues if you try to access it after the request has finished. You'll get a context not active exception. Code example: in a JSF page, or other view technology. Each time the page is submitted, a new request bean is created. @session scoped lifespan a @session scoped bean lives for the duration of a user's HTTP session. The session starts when the user first interacts with the application and ends when the session expires, due to inactivity or explicit logout. Use cases: storing user-specific information like login status, preferences, shopping cart data across multiple requests, or a user profile. Asterisk concurrency asterisk requires careful consideration. Multiple requests from the same user's session can access the same @session scoped bean concurrently. You'll need to use synchronization mechanisms, example synchronized blocks, java.utility concurrent classes, if the bean state is mutable and accessed by multiple threads. Asterisk serialization asterisk @session scoped beans are typically serialized to disk if the application server needs to replicate the session for high availability. Therefore, they must implement the java.io.serializable interface, and any injected beans must also be serializable or marked as @non-binding if they are not. Asterisk code example asterisk. In a JSF page. Asterisk @application scoped asterisk. Asterisk lifespan asterisk a @application scoped bean has a single instance for the entire application. It's created when the application starts and destroyed when the application shuts down. Asterisk use cases asterisk sharing application-wide configuration, caches, or singleton services across all users and requests. Think of it as a global variable, but managed by CDI. Asterisk concurrency asterisk extremely important. All users and requests share the same instance. You must use synchronization mechanisms, example synchronized, java.utility concurrent, to protect mutable state. Immutable data is fine. Asterisk serialization asterisk not typically serialized because there's only one instance for the application. Asterisk code example asterisk. In a JSF page. Key considerations and best practices asterisk. Asterisk choose the narrowest scope possible asterisk always start with the smallest possible scope that meets your needs, example @request scoped instead of @session scoped if the data is only needed for the current request. This minimizes resource consumption and potential concurrency issues. Asterisk understand concurrency asterisk if a bean state is mutable and accessed from multiple threads, especially @session scoped and @application scoped, use proper synchronization to avoid race conditions and data corruption. Asterisk serialization, for @session scoped make sure your @session scoped beans are serializable, implement java.io.serializable. Transient fields, transient keyword, are not serialized. Pay attention to injected dependencies, they need to be serializable too, or mark them as @non-binding. Asterisk injection asterisk consider using producers or custom scopes for more complex scope management scenarios. Question 2, I'm building a REST API with jax-rs. What's the best way to handle exceptions and return meaningful error responses to the client? Answer asterisk. Exception handling in jax-rs is crucial for providing a good API experience. You want to return informative error messages with appropriate HTTP status codes. Here's a breakdown of best practices and techniques. Asterisk web application exception asterisk. Asterisk this is the core jax-rs exception. You can throw a web application exception with a specific HTTP status code and an entity, the error message. Asterisk code example asterisk. Asterisk exception mappers, @provider and exception mapper T. Asterisk exception mappers are CDI beans that implement the jakarta.ws.rs.ext exception mapper T interface. They are automatically discovered by jax-rs and used to handle exceptions of type T, or subtypes of T. Asterisk this is the recommended way to handle exceptions in a structured and consistent manner. Asterisk code example asterisk. Explanation asterisk. 1. The @provider annotation registers the class as a jax-rs provider, making it available for use in exception handling. 2. The exception mapper exception interface specifies that this mapper handles all exception types, or you can create more specific mappers, like in my custom exception mapper. 3. The to response, method is called when an exception of the specified type is thrown in a jax-rs resource. For inside to response, you can log the exception, create a custom error message object, and build a response object with the appropriate status code and entity, the error message. 5. The error message class is a simple POJO to represent the error response. You can customize it to include any relevant information. Asterisk best practices asterisk. Asterisk specific mappers asterisk create specific exception mappers for different exception types, example entity not found exception, validation exception, authentication exception. This allows you to provide tailored error responses. Asterisk consistent error format asterisk define a standard format for your error responses, like the error message class above, to make it easier for clients to parse and handle errors. Use JSON, json-b/json-p, or XML for the error format. Asterisk logging asterisk log exceptions in your exception mappers for debugging purposes. Asterisk security asterisk be careful not to expose sensitive information in your error messages. Avoid including stack traces in production error responses, as they can reveal implementation details. Asterisk HTTP status codes asterisk use the appropriate HTTP status codes to indicate the type of error, example 400 bad request, 401 unauthorized, 403 forbidden, 404 not found, 500 internal server error. Asterisk consider jax-rs filters and interceptors asterisk filters and interceptors can also be used for exception handling, but exception mappers are generally the preferred approach for REST APIs because they provide a cleaner separation of concerns. Asterisk simplified example. Question 3. How can I implement proper authentication and authorization in my Jakarta EE application, and what are some common pitfalls to avoid? Answer asterisk. Security is paramount. Here's an overview of authentication and authorization in Jakarta EE, common approaches and potential pitfalls. Asterisk authentication versus authorization asterisk. Asterisk authentication asterisk verifying the identity of the user, example confirming that the user is who they claim to be. Common mechanisms include username/password, OAuth, OpenID Connect, and certificate-based authentication. Asterisk authorization asterisk determining what a user is allowed to do, example whether they have permission to access a specific resource or perform a particular action. This is typically based on roles or permissions. Asterisk Jakarta EE security mechanisms asterisk. Asterisk servlet security, declarative security you can define security constraints in your web.xml, or equivalent annotations in Jakarta EE, to restrict access to certain URLs based on roles. Explanation asterisk. Asterisk the security constraint element defines a security rule. Asterisk web resource collection specifies the URLs to be protected, example /admin/**. Asterisk auth constraint specifies the roles required to access those URLs, example admin. Asterisk login config configures the authentication mechanism, in this case, form-based authentication. Asterisk security role defines the roles used in the application. You also need to configure the application server to authenticate users, example using a database realm, LDAP, etc. Asterisk jax-rs security, declarative and programmatic you can use jax-rs annotations like @roles_allowed, @permit_all, and @deny_all to control access to REST endpoints. You can also programmatically check roles using security context. Explanation asterisk. Asterisk @roles_allowed, admin, restricts access to the admin resource to users with the admin role. Asterisk @context security context injects the security context, which allows you to access the authenticated user's information and check their roles programmatically. *CDI security, programmatic. You can use CDI interceptors to enforce security rules programmatically. This provides more flexibility but requires more code. Explanation ***. The @secured qualifier is a custom annotation that marks methods or classes to be secured. **The secured interceptor is a CDI interceptor that intercepts calls to methods annotated with @secured. Inside the interceptor, you can use the security context to check the user's roles and grant or deny access accordingly. Jakarta Security API, introduced in Jakarta EE8, it provides a standard API for authentication and authorization. Common pitfalls storing passwords in plain text. Never, ever store passwords directly in the database. Always use a strong hashing algorithm, example BCRYPT, Argon2, with a salt. Insufficient input validation. Validate all user input to prevent injection attacks, SQL injection, cross-site scripting. Cross-site scripting, XSS properly encode output to prevent XSS vulnerabilities. Use context-sensitive encoding. Cross-site request forgery, CSRF implement CSRF protection mechanisms, example synchronizer tokens, to prevent attackers from executing unauthorized actions on behalf of authenticated users. Insecure session management. Use secure session cookies, HTTP only, secure, and set appropriate session timeouts. Regenerate session IDs after login. Lack of authorization checks. Always perform authorization checks before granting access to resources or performing actions. Don't rely solely on authentication. Over permissive roles. Avoid granting overly broad roles to users. Use fine-grained permissions whenever possible. Principle of least privilege. Hard-coding credentials. Never hard-code credentials in your code. Use configuration files or environment variables to store sensitive information. Ignoring security updates. Keep your application server, libraries, and dependencies up to date with the latest security patches. Using default configurations. Change default passwords and configurations. Not using HTTPS. Use HTTPS for all communication between the client and server to protect sensitive data in transit. External libraries and frameworks. Shiro. A popular Java security framework that provides authentication, authorization, session management, and cryptography features. Spring Security. Another widely used security framework, especially in Spring-based applications. OAuth 2.0 and OpenID Connect. Standard protocols for delegation and authentication, often used for integrating with third-party identity providers. Choosing the right approach. For simple applications, declarative security, servlet security, might be sufficient. For more complex applications, programmatic security, CDI interceptors, jax-rs security context, or external frameworks, Shiro, Spring Security, offer more flexibility and control. For modern web applications, consider using OAuth 2.0 or OpenID Connect for authentication. Key takeaways. Security is a multi-layered problem. Follow security best practices to minimize vulnerabilities. Use appropriate security mechanisms for your application's complexity. Stay informed about the latest security threats and vulnerabilities. Question 4. What are some strategies for testing Jakarta EE applications, and how can I integrate testing into my CI/CD pipeline? Answer asterisk. Testing is essential for ensuring the quality and reliability of your Jakarta EE applications. Here's a breakdown of testing strategies and CI/CD integration. Asterisk types of tests asterisk. Asterisk unit tests asterisk test individual components, example CDI beans, jax-rs resources, JPA entities, in isolation. Use mocking frameworks, example Mockito, EasyMock, to isolate the component under test from its dependencies. Asterisk example asterisk. Asterisk integration tests asterisk test the interaction between multiple components, example a jax-rs resource that interacts with a JPA entity manager. These tests typically require a running application server or an embedded container. Asterisk example using Arquelion asterisk. Explanation asterisk. Requires Arquelion setup in your project. The at deployment creates a deployable archive for the test. Injects the entity manager to interact with the database. Tests persisting and retrieving an item entity. Asterisk end-to-end tests, E2E tests test the entire application flow from the user interface, UI, to the database. These tests are the most comprehensive but also the most complex to write and maintain. Use tools like Selenium, Cypress, or Playwright. Asterisk testing frameworks and tools asterisk. Asterisk JUnit asterisk a popular unit testing framework for Java. Asterisk Mockito asterisk a mocking framework for creating mock objects in unit tests. Asterisk Arquelion asterisk a testing framework for integration and end-to-end testing of Java EE applications. Asterisk Selenium, Cypress, Playwright asterisk tools for automating web browser interactions in end-to-end tests. Asterisk REST assured asterisk a Java library for testing REST APIs. Asterisk test containers asterisk a library for running Docker containers in your tests, example for database testing. Asterisk CI/CD integration asterisk. 1. Configure your build tool, Maven or Gradle. Add the necessary dependencies for your testing frameworks and configure the build tool to run the tests during the build process. 2. Create a CI/CD pipeline, example Jenkins, GitLab CI, GitHub Actions, Circle CI. Asterisk check out code asterisk the pipeline should start by checking out the code from your version control system, Git. Asterisk build the application asterisk build the application using Maven or Gradle. Asterisk run unit tests asterisk execute the unit tests. Fail the build if any tests fail. Asterisk run integration tests asterisk deploy the application to a test environment, example a Docker container, and run the integration tests. Fail the build if any tests fail. Asterisk run end-to-end tests asterisk execute the end-to-end tests. Fail the build if any tests fail. Asterisk code analysis, optional run static code analysis tools, example SonarQube, to identify potential code quality issues and security vulnerabilities. Asterisk deploy to staging, optional deploy the application to a staging environment for further testing and user acceptance testing, UAT. Asterisk deploy to production asterisk deploy the application to the production environment. 3. Automate deployment asterisk automate the deployment process using tools like Ansible, Terraform, or Kubernetes. 4. Monitor your application asterisk monitor your application in production to detect issues and ensure performance. Asterisk best practices asterisk. Asterisk write tests early and often asterisk follow test-driven development, TDD, or behavior-driven development, BDD, principles. Asterisk aim for high code coverage asterisk strive to achieve high code coverage with your tests. Asterisk keep tests independent asterisk tests should be independent of each other. Asterisk write clear and concise tests. Asterisk tests should be easy to read and understand. Asterisk use meaningful assertions. Asterisk assertions should clearly indicate what you are testing. Asterisk run tests frequently. Asterisk run tests as part of your CI/CD pipeline. Asterisk use a testing pyramid. Asterisk emphasize unit tests, followed by integration tests, and then end-to-end tests. This helps to reduce the cost and complexity of testing. Asterisk mock dependencies carefully. Asterisk only mock dependencies that are external to the component under test. Avoid over-mocking. Asterisk use test data management. Asterisk manage test data effectively to ensure consistent and reliable tests. Asterisk automate test data setup and cleanup. Asterisk automate the creation and cleanup of test data to avoid side effects. Asterisk use assert-j for fluent assertions. Asterisk provides a more readable and fluent API for writing assertions. Asterisk use faker for realistic test data. Asterisk generates fake data like names, addresses, and dates for testing. Question 5. How can I effectively use json-b and json-p in my Jakarta EE application for serializing and deserializing JSON data? Answer asterisk. JSON-b, JSON binding, and JSON-p, JSON processing, are two APIs in Jakarta EE for working with JSON data. Here's a comparison and examples. Asterisk JSON-p, JSON processing. Asterisk purpose. Asterisk provides a low-level API for parsing, generating, and transforming JSON documents. Asterisk approach. Asterisk uses a streaming or object model approach. You work with JSON reader, JSON writer, JSON object, JSON array, etc. Asterisk control. Asterisk gives you fine-grained control over the JSON structure and serialization/deserialization process. Asterisk.